Ever wondered why we can remember the past but not the future? We live in a world where time is always moving forward, never backward. We experience life as a continuous flow, with moments passing one after the other, like the steady ticking of a clock. We grow older, not younger. We remember yesterday but not tomorrow. But have you ever stopped to ponder why that is? Why can't we remember the future like we remember the past? Why don't we grow younger instead of older? Why does time only move in one direction? These questions might seem strange, even impossible. But in the realm of science, they lead us to the fascinating concept of time's arrow. It's a topic that has intrigued scientists, philosophers, and thinkers for centuries. Today we delve into this fascinating concept. Let's embark on a journey to unravel the mystery of time and its unidirectional march. Time, as we know it, is a one-way street. From the moment we're born to the moment we draw our last breath, we're constantly moving forward, from the past into the future. We grow older, not younger. We can remember yesterday but not tomorrow. We can't unscramble an egg or put spilled milk back into the bottle. This forward march of time is something we take for granted. It's a fundamental part of our reality, woven into the very fabric of the universe. Time ticks on, second by second, minute by minute, inexorably pulling us along in its current. But have you ever stopped to wonder why time behaves this way? Why does it only go in one direction? Why can't we turn back the clock, reverse its hands, and journey into the past? This is a question that has puzzled scientists and philosophers for centuries. Some have argued that the unidirectional flow of time is simply a fundamental law of nature, as inviolable as the speed of light or the force of gravity. Others suggest that it's a consequence of the initial conditions of the universe. They point out that at the moment of the Big Bang, the universe was in a highly ordered state, and it's been moving towards disorder ever since. Then, there are those who propose that time might be reversible in some other universe, or in some hidden corners of our own universe that we've yet to discover. Whatever the reason, the fact remains. Time, as we experience it, moves in one direction, from the past, through the present, and into the future. It's a journey we're all on, whether we like it or not. But why can't we reverse time? Let's explore. In the world of physics, most laws don't care which direction time is flowing. Whether time is moving forward or backward, the laws of physics remain the same. This symmetry of time is a fundamental aspect of physics, from the motion of planets to the interactions of particles. Imagine you're watching a film of a planet orbiting the sun. If someone hit the rewind button, the planet would simply appear to orbit in the opposite direction. The laws of motion don't care which way time is moving. This is true for most laws of physics, from electromagnetism to quantum mechanics. They're time-symmetric, meaning they work the same regardless of the direction of time. But there's a catch. There's one rule in the universe that doesn't follow this time symmetry, and that's the second law of thermodynamics. This law states that the total entropy, or disorder, in an isolated system can never decrease over time. In other words, things naturally move from a state of order to disorder. Picture a hot cup of coffee sitting in a cold room. Over time, the heat from the coffee spreads out, warming up the room while the coffee cools down. This is an increase in entropy. The coffee and the room have gone from a state of order, with hot and cold separate, to a state of disorder, with the heat spread out. If you hit the rewind button on this scenario, it would look very strange. You'd see the room getting colder while the coffee miraculously heats up. It's not something we'd ever observe in nature. This is what scientists refer to as time's arrow. It's the direction of increasing entropy, and it gives time its forward direction. It's why we remember the past and not the future, why we grow old, why coffee always cools down in a cold room. Yet, the second law of thermodynamics tells us that time can only move forward. Entropy is the key to understanding why time doesn't flow backward. Now let's simplify this concept. Imagine you have a deck of cards all neatly arranged in order. Now if you start shuffling them, what do you think will happen? The cards will start getting out of order, right? This is what we call increasing entropy. It's a measure of disorder or randomness in a system. Now, if you keep shuffling, it's highly unlikely that the cards will return to their original order. This is because there are far more ways for the cards to be out of order than in order. The same principle applies to time and the universe. There are more ways for things to be disordered than ordered. As time moves forward, things tend to go from an ordered state to a disordered state, increasing entropy. Consider a hot cup of coffee in a chilly room. Over time, the heat from the coffee disperses into the room until the temperature of the coffee and the room equalize. This represents an increase in entropy. The heat energy is more spread out, more disordered. What you'll never see is the heat energy spontaneously concentrating back into the coffee, making it hotter while the room gets colder. That would represent a decrease in entropy, and it's not something that happens naturally. So you see, the irreversible nature of entropy increase gives time a direction. It's like a cosmic arrow pointing forward, dictating the flow of time. It's why we remember yesterday but not tomorrow, why we grow older, not younger. Entropy is the reason you can't unscramble an egg or put spilled milk back in the jug. It's why, even if you could turn every particle in the universe around and send it back the way it came, you could never truly go back in time. So, the increase of entropy sets the direction of time. Time marches forward, not backward, and entropy is the drumbeat it steps to. Our memory is another clue to the direction of time. Let's dive into the realm of human cognition. Our minds are incredible machines, capable of storing and recalling vast amounts of information. But have you ever noticed that our memories are inherently one way? We remember what we ate for breakfast yesterday, the name of our first pet, or the feel of a summer breeze from our childhood. But can you remember what you'll have for dinner next week, or the name of a pet you might have in the future? Of course not. This is because our memory, like time itself, moves in one direction. It's a record of the past, not a prediction of the future. This one-way flow of memory is something we take for granted, yet it's deeply intertwined with our understanding of time. The arrow of time doesn't just govern the physical world, it also shapes the landscape of our minds. Our brains are wired to process information in the order in which events occur. We form memories based on past experiences and use those memories to navigate the present and anticipate the future. But we can't remember the future because it hasn't happened yet. There's no information for our brains to process. This asymmetry of memory is tied to the concept of entropy, the measure of disorder in a system. In the natural world, systems tend to evolve from a state of order to a state of disorder. This is the direction of the arrow of time. Our brains, as part of this natural world, follow the same principle. As we experience life, our brains process and store information, creating memories. This process increases the entropy or disorder in our brains, marking the forward passage of time. So why do we remember the past and not the future? It's not just a quirk of human cognition. It's a reflection of the fundamental laws of physics that govern our universe. Our perception of time, our memories, our very existence are all shaped by the relentless forward march of time's arrow. Our perception of time is tied to the laws of physics and the workings of our brain. So, can we ever reverse time? We've journeyed through the concept of time, examining its scientific underpinnings and grappling with the idea of time reversal. We've seen how the laws of physics, for the most part, remain indifferent to the direction of time. Whether we're talking about Newton's laws of motion or the principles governing the flight of a thrown ball, time could just as well run backwards. However, we've also delved into the realm of thermodynamics and encountered the second law, which introduces the concept of entropy. This law, unlike others, distinguishes a clear arrow of time from order to disorder, from the past to the future. This is why we can scramble an egg but can't unscramble it. The flow of time, it seems, is firmly rooted in the forward direction. We can remember the past, but the future remains a mystery, waiting to unfold.